right? So first, let's try to understand what this one function or injective function means, right? So they say check whether the given function is one, or they say check the injectivity of the function. Injectivity is a property of the function, right? So as the name suggests, it's very simple. This stands for input, this stands for output. If every element in the function, right, has a unique output associated, then you call it as a one function, right? So if I define a function f from a set x to set y, right, it is said to be one or injective if the images of distinct elements of x under f are distinct for every x1 comma x2 that belongs to the capital X. Means if I take two elements from the set A, that is set x, x1 and x2, if they are two unique elements, they should have two unique outputs, right? So if that kind of a condition is satisfied, you call it as one, or else you call it as many to one. Means many inputs are having the same output. So let me show it diagrammatically so that you will understand it better. Suppose this set x, this set y. Okay, x1, x2, so on till xn, y1, y2, so on till let's say yn. And first point to be noted is not necessary you have equal number of elements in both the sets. But what are the minimum number of elements you need to have in set y for it to be 1, 1? Minimum number is the number of elements that are in set x. If suppose you have lesser number of elements, what will happen? For it to become a function, two elements should get mapped to one. Are you able to understand what I'm trying to say? So x1, if it is mapped to y1, x2 is mapped to y2, so on till xn, let's say it is mapped to yn. Suppose you have y of n plus 1 also, means you have an extra element also. Still, this can be called as a one-to-one function. Why? Because each element of set A is associated only to one element in the set B. Right? Suppose instead of this, x1 is mapped to y1, x2 is also mapped to y1. Right? Similarly, xn to yn, but all the other elements have some image associated. In this case, what is happening? Since two inputs are associated with the same output, this will not be a one function, rather it will become a, right? See, this is one way of understanding. I hope I'm clear, right? This is one way of understanding using the Venn diagram. Not necessary that you will use Venn diagram every time. Right? Sometimes you will have to use the graphical analysis to find out. Sometimes you don't know how to draw the graph. Rather, you need to use a mathematical operation to find out whether it is a one function or not. Right? For that, how you're going to do is observe. Right? So first you can make a note of this. First make a note of this point. I'll give you the steps. How to mathematically prove that a given function is a one function. How do you do that? Suppose they give you a function which is mapped from from set x to set y. There is a function that is mapped from set x to set y, right? And let's say they are giving you a function like this. F of x is equal to, I'll take one of the function to be x for simplicity, and I'll take the other function to be f of x is equal to x square. Okay, since you know what these functions actually mean. So when I say f of x is equal to x, the thing that should run in your mind is y is equal to x and y is equal to x square. Have this in your mind as well. So I'm concentrating on the left hand side. So in this set x, I will take two elements, right? The first step is consider two elements. So you can write it along with me. So consider two elements x1 comma x2 that belongs to the set capital S. Okay. Second, assume f of x1 is equal to f of x2. Assume f of x1 is equal to f of x2. Okay. Third, after substituting x1 comma x2 in f of x in the previous step, solve the equation to find the relation between x1 comma x2. To find the relation between x1 comma x2, if x1 comes out to be equal to x2, then it is a one function. If x1 is not equal to x2, then it is a many to one function. So this is what you need to do universally. Whatever function they give you, these are the 4 steps to be followed. Am I clear with this? So let's see how to apply it. But as of now, make a note of this. So I took the function y is equal to x, and I took the function y is equal to x square. Okay, now we'll apply those 4 steps to this function and see. So what is the first step? So let's say y is equal to y is equal to x is a function defined from real number to real number. It's defined from R to R. So what is the first step? Let x1 comma x2 be values which belong to, in this case, that x is R. Consider x1 comma x2 that belongs to R. Right? What is that we need to assume? F of x1 is equal to f of x2. So what is the value of f of x1 here? It's very simple. X1 and f of x2 is x2. Since x1 is equal to x2, it is a 1, function. It's a very simple question that I've taken. Okay, we'll extend it to the next one also. But I hope these steps are clear. Now we'll apply the same steps and see. Let x1 comma x2 belongs to, now I need to know what is the domain. Right, whenever they give you a function, right, don't blindly start solving. First start looking at what is the domain and the codomain. Right? So f is a function mapped from R to R. So what should I put here? Right. Now, f of x1 is equal to f of x2. So what is f of x1? x1 square is equal to, what is f of x2? x2 square. Normally, what do we write? We write x1 is equal to x2. Taking the square root on both the sides, it is x1 is equal to x2. No. But it is not x1 is equal to x2. It is x1 is equal to plus or minus x2. Because we take the modulus on both the sides. So when I square this, whether it is a minus or a plus, I'm still going to get the same value. So what is this telling me in a deeper picture? X1 can be x2, or x1 can be negative of x2 also. So it is not satisfying this unique condition. Hence, this will be it is not a 1, function, rather it is a many to one function. Means many inputs generate to the same output. Listen to this. Listen to this. So one thing I told you is how to analyze with the help of Venn diagram. I hope that part is clear. So in a Venn diagram, if 2 arrow marks are going to the same image, it's a many to one. If each arrow mark is going to a unique image, it's a 1 to 1. Right? This is the way you are supposed to write in the exam. So this is what they expect. Right? This is for CBSE perspective. But to go on a slightly deeper picture, where, as I told you, this chapter is important for calculus, right? I want to put this in your mind. How to analyze this graphically, at least for simple functions like this. So you know, how does this function y is equal to x appear when you draw it on a graph sheet? Right? How it is going to appear? So it's a straight line that is passing through the origin, right? So this is how it will go, right? Where this angle is going to be 45 degrees. right? Basically, last year you would have learned the same function as an identity function also. Both are same, right? Similarly, y is equal to x square. If I plot it on a graph sheet, how is it going to look like? What kind of a parabola? Is it upward, rightward, downward, leftward? It's an upward U-shaped parabola. How did you say that? Because the coefficient of x square is positive. So y is equal to x square represents an upward parabola like this. Am I clear with both the diagrams? Right. See, this part which I'm going to explain is nowhere in your textbook. So listen to this carefully. There is something called as horizontal line test. So when a graph is given to you, right, if you draw a line horizontal in the sense parallel to x-axis either above or at the bottom, when you do the test, right, and if that line cuts the graph only at one point, then it will be a 1-1 function. You draw this line is cutting this graph only at one point. Whereas in this case, if you draw, it is cutting the graph at more than 1 points. So this is the meaning of x1 is equal to x2 and x1 is equal to minus x2, meaning I can put 2 here, which will generate a value of 2, 4, or I can put minus 2 here, which will still generate the value of minus 2, 4. Like how we told in the case of a function, the first element in the ordered pair should be unique. For it to be a 1-1 function, the second element in the ordered pair should be unique. Is it unique? The second element in the ordered pair is 4 and 4. It's not unique. Hence, it's a many-to-one function. So these are the different perspectives in which we can see. But as I told you, this is the part they expect in your exam. Right? So these kind of applications will help you in a chapter called as applications of integrals, where you need to draw the graph. So yeah. So always start looking in the perspective of drawing a graph. At least for simple functions like this. Am I clear with this? Now we can make a note.